Good afternoon, electronics friends. Alright, now it's time to get back to the thing that kind of stopped me on episode 1, and then the other thing that stopped me from doing that, which is basically I wanted to add a couple of LEDs to this thing here, which is my power rail project, which ultimately 12 volts, 5 volts, ground. I just want the ability to connect a wire, let's say, let me just grab a random wire here. If I had this wire here and I wanted to hook it in, I want to be able to, let's say it's 5 volts, this would be the positive side of the 5 volts, and I would push the wire in there. I don't know how well you're going to be able to see that. And then push the little lever down and that would hold it. But ultimately I need to connect the actual 5 volt source and the 12 volt source to these two, and then I need to hook up to ground. Anyway, the whole thing from that episode was that I wanted to put an LED, say, right next to this for 5 volts and another LED for 12 volts, so that I have an indication when I have this, when I'm connecting into this, that the power is actually available. The problem I ran into was that the first problem was that a couple of LEDs that I had selected that I took off a board, a red and a green, and these just weren't going to work. So I needed different LEDs. So I started putting together LEDs on a breadboard, and these things are great for just trying an idea out without committing to soldering everything together. And really all you need for a circuit like this is you need the actual LED that you're going to use, that you want to turn on, and you need a resistor. Now the question is, what value of resistor? Well, I started doing some calculations. Flip that around, not that you're going to be able to read the whole thing. I started doing some calculations, and I hooked up the LED, and one thing led to another, and I ended up with kind of this mess here. I tried one LED, or one resistor, and the LED just wasn't bright enough. So, alright, as it turns out, by the theory, if you reduce the resistance, then the LED will get brighter. If you think about it, that's kind of like saying, if you adjust a valve on a water pipe, you can get more water to flow. Well, I kept reducing the resistance and it wasn't making any sense. So I think what's happening is this is a really old style LED. Let me actually pull the other one out. I just happened to select these because I had them handy. And you can see this thing is really tiny. This is like a, I think that may actually be a 2 millimeter LED. The most common one is a 5 millimeter. But because it's a really old technology, usually they run, a red LED usually runs on about 2 volts, 2.1 give or take, and it wasn't getting very bright. And I was figuring, okay, I'm so used to, with modern LEDs, you put 5 milliamps into it and you get a nice bright LED. These old ones required 20 or maybe even 30 milliamps to really light up. And so I initially did my calculations at 5 milliamps. That wasn't bright enough. I reduced it down to the point where it's going to be at about 10 milliamps. And that still didn't seem bright enough. So ultimately, I decided, okay, I got another tool in the toolbox here, as I try and put that LED away without actually knocking it off the workbench and losing it. And that tool is my resistor substitution box, which, the beauty of this is I could set this thing, let's say, all the way down to, what is that, 15 ohms. And now ultimately, actually, let me give you a better example. When I started working with the 12 volt supply, I came to the conclusion I needed a 1 kilo ohm resistor, which is way up here, 1000. And so what would have been beautiful would have been if this was hooked into the circuit while I was testing, And I could have just said, oh, that's not bright enough. Okay, let's knock it down a notch. Oh, that's not bright enough. Knock it down another notch. Not bright enough. Just keep going until you get the brightness that you want. That would have been beautiful if I could have done that, except that there was one particular resistor missing. So I just did a video where I actually fixed this unit. So now I can put this to use with one of these breadboards and an LED, and I can try and figure out with the 12 volt source and with the 5 volt source which one seems to give me. I want to get my resistors set so that the 12 volt and the 5 volt, which are two different voltage sources running two different LEDs, I want them to be about the same brightness. So I actually need to go grab the 12 volt and 5 volt power source, which I forgot to grab, and I'll be right back. So here we go. Okay, how's that for quick? So I've now got the 12 volt ready to go. What we need to do is we need to wire up the circuit. And actually, before I even show you that, let's talk about the circuit. Let me get a piece of paper here. And a pen. Let me move that out of the way. Eventually this whole workbench is going to be organized to the point where I won't have to keep pulling stuff out of the corners, and it'll all be nice and set up on here. So I'm going to be happy when I get to that point. Also, it's kind of warm today. I have a plan to put a fan up here just blowing right in my face. That'll make me happy, but for that I need the 12 volt supply, and for the 12 volt supply I need the board, and for the board I need the LED, which brings us back to how do you figure out what resistor you're going to put on an LED? So in order to solve for that, the 10 volts divided by 10 milliamps is going to be equal to 1,000 ohms. And that's ultimately where I started when I had the problem with the 12 volt. But the LED wasn't very bright. And so let me demonstrate what that ends up looking like. We're going to go ahead and wire that up. Now, let me pull out these massive resistors here. It's just all my failed attempts. But I'm going to go back to, let me make sure I'm looking at the right one. Yep. That's the 1K resistor. I'm going to get that up close so you can see, hopefully. I don't know if that's going to come into focus or not. But I've got my breadboard set up with little jumpers here from, if I call this the positive and that the negative, then I've got a jumper coming across to here because it doesn't automatically come across. You need to probably look at how breadboards work. Maybe I'll do an episode on that. But I'm actually going to run this like that. Okay, now I've got my 1K resistor in there. Here's my LED. Now the LEDs, another thing you need to know is they usually have two different size leads. And hopefully you can see one is longer than the other. And in another episode, I mentioned a simple way to test LEDs is with a button cell battery. So I'm going to go ahead, the longer lead is usually the positive, and I know the larger side of the battery is positive. So I'm going to go ahead and hook that up, and you can see I've lit up the LED. Now I'm actually running 3 volts through this LED, which I'm not supposed to, so I'm going to disconnect that pretty quickly. But it verifies that this is actually working, and I now know which side for sure is the positive side. So I'm going to hook that up in my breadboard. And that's what I've got it all hooked up. So now I'm going to plug in my 12 volt supply, which is, actually I should show you this. It's literally just an old wall wart. It was 12 volts. And I have cut off the original end and put a couple of alligator clips. Makes life easier for tests like this. This ultimately will make it easier than that. So there's my positive. Now as soon as I touch the negative, you should see it light up. And it's not lighting up. Okay, that's not a good sign. I'm going to pull that out just to be safe. Let's see. Oh, there's the problem. The resistor's not pushed in the right hole. Let's correct that. See, if it's not connected, it's not going to work. But now I've got the whole thing set up. Positive on this side. There we go. Now it's lit up. Can you tell? I can't. I mean, I almost can't. Now, so the problem here is I want this thing to get brighter. I don't want to cook it, but I want it to get brighter. There's one more thing I need to consider, and that is the resistors I'm going to use are probably going to be 1/4 watt resistors. Oops, wrong one. So let's get another piece of paper. The other calculation we need to know is power equals voltage times current. Now, if I'm running 10 volts across that resistor, and I have a certain amount of current, I need to make sure I'm not exceeding the power capacity of that resistor. Resistors basically convert energy into heat. And so if you put too much energy through them, they heat up too much and they burn. So they're rated for a certain amount, and most of these are 1/4 watt resistors. Power is measured in watts. If I got 10 volts and I multiply by the current, let's say in this case, I'm assuming 10 milliamps for the current. So ultimately, that's 10 divided by 100. So that is 0.1 milliwatts. Which is 100 milliwatts, or 100 out of 250 milliwatts. So at that rate, I'm good. At 10 milliamps, I'm good. But the real question is, how far can I go before I end up burning up that resistor? So I got to consider that it's actually 0.25 is the rating of the resistor, is equal to 10 times I. So if I divide by 10 on both sides, I've got 0.025 equals I. Or 25 milliamps. So that's my answer, 25 milliamps. Now if I work backwards, remember we've got E over IR, and I know I and I know V or E, and I want the resistor. So basically R is equal to E over I, which is the 10 volts divided by 0.025 why I brought out both of my meters. Actually, I have a third meter, but it's in really bad condition. So we're going to set this thing on volts. And we're going to set this one on milliamps. I'm going to go to 200 milliamps just to be safe. And what I can do here, since what I'm trying to test is the current going into the circuit, I can disconnect the negative lead here, connect the negative here, connect the positive, is that right? Yeah. That should give me the current, and I don't know how well you can see it, but it's basically showing 1.1 milliamps. That's curious. I had calculated this all out at 10 milliamps. Makes me wonder if my math was off by 10. I can actually then lower the range. I'm getting 1.05. Now, I haven't hooked up the voltage just yet, so let's see if there's something curious about this particular LED. Let's see. Positive's going to be on the left here. This is really small, so I know you can't see it. But I'm going to try and set it up so you can actually see it with the meter. And that should be the voltage across. Wow, it's not even registering. I'm doing something wrong. Alright, let's do this another way. Let's do it across the resistor. See how much voltage that resistor is actually dropping. According to this, it's only dropping 3 volts. That's not good. Oh, I see why. I've got it set on AC volts. Big mistake. Alright, let's try that again. Now it should hopefully make more sense. The voltage across the resistor, I'm getting in millivolts. That doesn't make sense. Wow, this is going wrong really quickly here. Okay, that makes more sense. I'm dropping 10.5 volts, which means I'm only giving the LED 1.5 volts. Alright, well, ultimately now the next trick is for me to employ the resistor substitution box. So we're going to leave, let's make sure these are still in frame. Hopefully you can still see those. We're going to put the substitution box right here. This is not polarized, it doesn't matter which direction I hook up in, but I do need, let's see, how am I going to do this? I need another wire because I've got alright. Let's connect up to the positive side. Then we can hook the resistor substitution box in. I'm just realizing that while I turned this to make more sense to you, because everything's kind of upside down as I'm shooting, it actually, these are in the other direction. So my apologies for that. I'm still learning how to do this whole thing with the overhead camera. Now what I need is another wire. Oh, perfect. That's what I should use to begin with. Alright. So I'm going to go the negative side, which is actually still the positive side of the LED. And I can hook in, let's make sure my box is set properly here. We want to be on 1K to start with. if I'd done that, whoops, wow, that got bright really quickly. That does seem a lot brighter, doesn't it? Maybe the resistor I was testing with wasn't right, but alright, it looks like it's saying we're pulling 9 milliamps. Now I'm actually going to go up to the 200 because if I exceed 20 then this will not blow up, but it'll go out of range. So we're at 9 milliamps, and the question is how much across the resistor. Well, now I can test it up here. I can put my 2 probes in there, and now I've got 10.5 across. Wow, I guess this LED actually only requires 1.5 because ultimately in LED the D is diode, and diode is designed to turn on at a certain voltage. So that's part of what was causing me my problem. I was calculating on 2 volts, I should have been calculating on 1.5. Now I've got a reasonably bright, but I want to get it a little bit brighter than that. So I'm going to drop it down, and hopefully you can see as I drop it, actually let me go the other way. Let's watch it get dimmer as I go through each of these selectors. And you can see it's basically disappeared at this point, at least from your perspective. I can still see it on. The studio lights are probably swamping it out. So I'm going to go back up, and I'm going to find a reasonable brightness that would give me a good indication that things are on. And I'd say that's pretty good there. And that is, oh wow, magically right at 330 ohms, which is the one that I had to replace to fix this. Okay, so the remaining question is what kind of voltage, what kind of current, and am I going to exceed the power rating of that resistor? So now we can go back and double check this. We basically have, according to this meter here, we're running about 30 milliamps into that resistor. 30 milliamps across 330 ohms is going to give us 30 times 330 would be 9,900, but we've got to get the decimal right. So 330, 30 milliamps is actually 0.03. So 990 shifted over to his 9.9. No. Okay, so now we've got it kind of established. The next thing we need to figure out is how these ratings are going to work and if I'm going to end up burning out that resistor. Now granted, it's been running actually for a little while because I had to take a pause, but I ran and got my calculator. Trust me folks, I could do the math. I'm just, for some reason, I guess because I'm on camera, I'm having a bit of a problem here. So, if we look at it, it's basically showing about 30 milliamps here that is being drawn through the circuit. That means 30 milliamps going through that resistor, and the resistor is dropping, in this case it's showing 10.1 volts. So it changes a little bit as you change the resistor, but to do the calculation, what I need here is I need my 10.1 volts times 0.03, which is 30 milliamps, equals, there we go. It's actually drawing 0.30. It's actually drawing more than a quarter watt. So that's not good. That's going to overheat the resistor over time. Actually, what's in my substitution box here are like 2-watt resistors, so they're fine. They're not baking in there. But if I put a regular quarter-watt resistor in there, I'd be in trouble. So now what I'm going to have to do in order to solve that problem is I'm going to have to choose to dim this LED. So I'm going to go from the 330, I'm going to go up a step. And I just lost my connection on that. So I've gone up a step to 470. I'm only drawing 19.5 milliamps. I'm dropping 10.36, 10.3. I got a flaky connection somewhere. So, let me clear. I've got 10.3 volts times 0.0195. And now I'm down to 200 milliwatts. So now I'm in the safe range. So a 470 is what I actually need. That takes care of that one. Now I'm going to disconnect the 12 volts and we're going to do this all over again for 5 volts, but I'm going to go in a much faster fashion here. So there's the 12 volts out. You'll watch it fade. Okay. Now I need to disconnect my 12 volts. Let's just get that out of the way. Don't need that to get caught up in something and cause a problem. So now we know we need a 470. Let's just write that down. 12 volts, 470 ohms. Gotta hope I actually got a resistor for that. So now I need my 5 volt supply. And this is really janky, but ultimately it's going to be a bit more professional. Would you believe I'm using a USB cable for the 5 volts? So in order to do that, I need a USB adapter that I can plug in. So I'm going to go ahead and plug this in to here. Let's get it in the right direction. There we go. I've got my little alligator clips hanging off of this. Actually, alligator and a, I don't know what you call this yellow one here, a plunger. I'm sure there's a name for it. I'll go look it up. I'll put that in there in post-production right at the bottom of the screen. That's that one. Am I still connected? Oh, that's why. Okay. So this connects to that. So now I've got everything set. All I got to do is actually plug this in. This is very temporary, but it's enough to accomplish what I'm trying to accomplish here. So now I should have 5 volts. There we go. It just kicked in. I'm showing a 3.5 volt drop, negative. Okay, that's fine. And a 6.5 milliamp being drawn through the circuit. So the other question then becomes the resistor. I'm going to start with this. This is at 470. So that matches, which I'm not surprised that it's not the same brightness, because I'm not starting with the same voltage. But I'm dropping 3.5 volts. Oops. Clear. 3.5 times 0.0065. I'm drawing 22 milliwatts. I'm fine. I can go lower. I got that flaky connection. There's your 330. Basically, I think what I want to do is I want to have the same brightness, so I want to have the same current being drawn through it, which was about 20 milliamps. I'm at 14 at this point. Now I'm right there at 20. That should be the same brightness. And for that, I am dropping 3 volts, 2 point. That's the meter complaining. Let me just make it happy. Okay, 3 volts times 0.019, let's call it 7. And that's showing 59 milliwatts. So I'm absolutely fine on that, and I'm getting the same, I should be getting the same brightness on that. So the answer to that now is, how big a resistor was that? That was a 150 ohm resistor. So at 5 volts, I need a 150 ohm resistor. All right, now I've got that. We've completed our objective of figuring out what value resistors we need, and we can move on to the next video where I'll actually assemble the LEDs onto this board. So let me go ahead and clean up, and I'll see you in the next video. As always, I hope you're learning something.